Hello everyone, I am Aditya SV, currently studying engineering in Sri Venkateshwar Engineering. In this video, I will be explaining about static hashing. The the topic is from data structures and applications using C language. So here it goes. So this video will be about all about static hashing and the applications and advantages of the static hashing. Before getting to know what is static hashing, let us understand what is hashing. So hashing is a technique used to store and retrieve data effectively. It involves using a hash function to map data to fixed range of values called a hash table. Hashing is used widely in computer science, especially in databases, caching and searching. What does static hashing mean? So now we'll understand what is static hashing. So in static hashing, the size of hash table is fixed. Once the table is created, its size cannot change. This is ideal for situation where the number of elements to store is known in advance. So let us understand the key concepts in static hashing. First comes the hash function. A hash function takes an input and converts it to an index for the hash table. A good hash function minimizes collisions, ensuring keys and distributed evenly. So example for hash function is we will be using int data type here. So then the hash function, the keyword, then the parameters will be taken, and the return key will be calculated by using modulo function. Hash table. A hash table is an array where the hash function determines the location for each key. So example of hash table is like int hash table. So we will be creating a hash table named array. So the size of the given hash table will be 10 in this example. Collisions. Collisions occur when two key maps to the same index. For example, index key 1 is equal to 15, index key 2 is equal to 25. So when we do the modulo of key 1 and key 2 using 10, so the remainder will be 5 in both cases. So they both will be making the key will be mapping at the same position, like index 5 of the array. So there will be a collision of the data to get entered into the specified space. So this is known as a collision in static hashing. Collision resolution technique. Now let us understand what is collision in static hashing. Collision occurs when two keys map to same index. So if two keys map to a same index, indexing fault where the two data where we store the data. So it will be like two numbers or the two different data will be pointing to a same number. Then it will be a problem for sure. So for example, in this example we are taking two keys, key 1 and key 2. So when we take the index by using modulo operator, so both the indexes will be 5. So they will be mapping to the same point. So that's the issue in this. So that's called collision. Collision resolution techniques. To resolve this collision, we have two techniques: chaining and open addressing. So coming to chaining, we use a linked list at each index to store multiple keys. So we can see the example of chaining here. And coming to open addressing, we find an empty slot in the table and we send the data to that place. That's open addressing. Steps to implement static hashing in C. So now let us understand what are the steps we use in implementing static hashing. So first we define a static table. So hash table, we call it as hash table. So declaring an array for the hash table or an array of linked lists for chaining. So next function is like writing the hash function. Use a modulo operator for simplicity. Hash function is the main point in this static hashing. So see, for simple use we are using modulo function. We can use other functions like divide, division function. Many other functions can be used. So next one is insertion. Place a key at the calculated index. Handle collisions using chaining or open addressing. So here goes the example. We will be using a insert key where the function here is like, in the function hash function is key modulo 10. So we will be if there is any collision occurring, it will be handled using chaining or open addressing. The next implementation step is searching. So search function, we use search function here. Use the hash function to locate the index, then traverse the chain to find the key. Next, deletion. Locate the key using the hash function. Using hash function we locate the key, and then it's easy to detect it and delete it from the chain or the table of hash function. Application of static hashing. So coming to the application parts, static hashing is used widely in many areas. So first one is databases. Hashing is used for indexing to allow fast data retrieval. Example, searching for a record by an ID number. Next one is caching. So caching is like the quick memory which is stored for effective users. So here goes it. Web browsers use hashing to store cached pages or data effectively. In compiler also we use static hashing. So hashing helps in symbol tables which store variable names and addresses. Next one is password storage. Hash functions like MD5 or SHA are used to store hashed password. Next, data duplication. Hashing helps identify duplicate data by comparing hash values instead of the actual data. Coming to the advantages and disadvantages of static hashing. First, advantages: fast data insertion and retrieval, simple to implement in programming languages like C, predictable memory usage due to fixed table size. We can predict the amount of memory which we require as its fixed size one. So coming to the disadvantages part, static hashing doesn't adapt well to change in the number of elements. So if we want more elements, as the table is predefined, the fixed table size, so we cannot add more elements. So it's one of the disadvantages as well. So collisions can slow down operation if not handled effectively. If we are not handling collisions perfectly, or we are not using chaining or open addressing techniques, then the collision may make some errors in the program or the work. So coming to the conclusion part, so static hashing is an effective and straightforward technique for storing and retrieving data. It is particularly useful when the dataset size is fixed or predictable. Using C, we can easily implement static hashing with chaining or open addressing. So thank you for watching this video. Please like this video and please watch it for 4 minutes. Thank you. So basically I missed a part in static hashing. This is like the comparison between the different hashing methods. So one will be dynamic hashing and the other one you know as static hashing, which I explained in the video before. So let us now compare them both. So dynamic hashing, so it allows the number of buckets to vary dynamically. So in the sense there is no fixed number of the buckets, so we can increase or decrease the number of buckets dynamically. So but in static hashing, a fixed number of buckets is allocated to file to store the records. In static hashing there are only fixed numbers, so we cannot increase or decrease the size of the buckets to store the data. So in dynamic hashing, it uses a second stage of mapping to determine the bucket associated with some search key value. Coming to static hashing, it uses a fixed hash function to partition the set of all possible search key values into subsets and then maps each subset to a bucket. So in dynamic hashing, performance does not degrade as the file grows. If the file grows by its size, so the performance never gets low. So in static hashing, performance degrades due to the bucket overflow. Like, what is the bucket overflow? In the sense, the collision which occurs when there are two key values mapping to the same space. In dynamic hashing, the index entries are randomized in a way that the number of index entries in the each bucket is roughly the same. And in static hashing, it uses a dynamically changing function that allows the address space to grow and shrink with varying database files. In this table you can see the perfect form, like where static hashing is useful and where dynamic hashing is useful. So form of data where the static hashing is used is fixed size. So there should be a fixed size of data where we use static hashing, and if it's variable then we use dynamic hashing. So coming to data bucket, fixed number of data buckets are there in static hashing, and in dynamic hashing data bucket number vary dynamically. So bucket overflow. Challenge of bucket overflow can arise when the amount of data suppresses the available memory. In static hashing, this is the problem, but in dynamic hashing we can overcome this problem, as it is bucket overflow is not an issue in dynamic hashing. So use case, with databases of limited size we can use static hashing, where the database have large size or scalable data where the data keeps varying, so we can use dynamic hashing. Efficiency compared to dynamic hashing, static hashing has less efficiency, and in compared to complexity, static hashing is simple, and whereas dynamic hashing is more complex than static hashing. So that's it guys, thank you very much for watching this video.